process where the amount of vapor is increased by letting it in the gas stream, by letting it pass through a liquid stream, which also evaporates. It includes simultaneous heat and mass transfer. Humidification is usually used to control humidity or to recover water or cool it by contacting it with air that has a low amount of water vapor. The mass of water vapor here is carried by the mass of unit dry air, which is known as the humidity or the moisture content of air. The goal of humidification is to remove waste heat to reuse water. This is usually done in heat exchangers in industrial plants. Also, it is done for economical reasons because it allows minimization of expenditure. Humidification is carried through humidification equipments, which depend on unit size, convenience of recovering gas or liquid phases, and the materials of construction used. The most widely used humidification equipment is the cooling tower. Cooling towers are used for large and cooling duties. It is a heat rejection device because waste heat is extracted from the atmosphere or the input air by cooling a stream of water to lower the temperature. Also, it operates under the principle that cooling potential for a wet surface is better than a dry surface because there is a high temperature difference for the cooling liquid and the surrounding air, so the cooling potential is higher. Also, the heat from water to air increases temperature and relative humidity to 100% before it is discharged in the atmosphere. And so this heat rejection device is evaporative, since a small amount of water cooled is evaporated into air so that the stream of liquid from which the water is from would also be cooled. The mechanism of cooling towers include spraying the water from above the deck and then allowing it to trickle down as droplets, then collecting it at the bottom basin. Letting it trickle down as droplets is very important because it increases the area of contact between the water and the air. The purpose of cooling tower is to conserve cooling water by lowering temperature so that the water can be reused as many times as possible. It allows cost-efficient and energy-efficient operation for cooling. And in the cooling tower, the heat transfer process involves 80% latent heat and 20% sensible heat. Latent heat is due to the vaporization of the small amount of water. Meanwhile, sensible heat is due to the temperature difference between the water and the air. Now, for the factors affecting theoretical air removed per pound of circulated air, we have temperature and humidity. Humidity is indicated by the wet bulb temperature. It is the lowest temperature in which water can be cooled. However, the temperature of the wet bulb is never equal to the temperature of the cold air, but it only approaches it. This is because not all of the droplets come into contact with the air. Also, there is no latent heat transfer because the vapor pressure of water at the cold water temperature is only equal to the vapor pressure of the water at wet bulb temperature. From this, we can get the temperature of the cold water difference from the temperature of the wet bulb, and this is known as the approach. The approach is affected by the factors of the tower design, which include the air-to-water contact time, amount of filled surface, and the breakup of water into droplets. Approaches rarely exceed 2.8 degrees Celsius or 5 degrees Fahrenheit. Now for the parts and types, here are 9 other